In these video notes, we're going to talk about proofs and actually filling in proofs with our different lines. So it's the same setup that we did before for our algebraic proofs, but now we are going to be talking about our angles and our transversal lines with our parallel lines. So for these first three that I have shown up here, A, B, C, if the first line is given to you, how do they get the second line? We're just going to practice going through three different common ones you will be seeing so that when you see that, you will know automatically what your answer will be. So for letter A, you can see that the only difference between the first line and the second line is that now it is equals instead of congruent. So what we're going to say is that our congruence, that's what we start with. So because it is congruent, it implies that we will have equal measures. So if we change the congruence to now equals between two things, and it's the same two angles we are talking about, we know that our congruence implies equal measures. For letter B, we have that they start out being equal, so measure of angle 4 equals measure of angle 5, but now it says that the angle 4 is congruent to angle 5. What you want to look at is see that this is equals and now it changes to congruence. You have to ask, what does it start with? We see an equal sign, so we know that equal measures implies or tells us that they will be congruent to each other. So they're kind of the converse of each other for letter A and B. In letter C, that's also one we're going to see often in these notes, and we see if we are given that angle 1 and angle 3 are supplementary, so think of just from a picture, we're just told that they're supplementary, and that was given to us, then we can say that the measure of angle 1 plus the measure of angle 3 will be equal to 180 degrees. And we have to ask ourselves, what is the reason that we can write this? We know that supplementary angles is what we start with. That has to tell us something. So because they are supplementary angles, that implies that the sum of our two angles is equal to 180 degrees. Now we are going to get into the actual proofs themselves and filling out all of the different reasons. On this one, you are given the statements and you need to fill in all the reasons. On the first line, we always want to look for the given statements. So it gives us that line L and M are cut by transversal line T. That is right here at the first line. It also tells us that angle 1 is congruent to angle 2. So if it's given to us, we can write that in our picture. And that's also given to us in line 1. So we know that our first statement up here, first reason, is going to be the given. Next, you have to ask yourself, how do they get that measure of angle 1 is equal to the measure of angle 2? So you have to look at what you were told previously. We can see that the angle 1 is congruent to angle 2. And how does it change from congruent to equal? Is because congruence implies equal measures. Next, it pairs up 2 and 3 are supplementary. On this one, when we look above, they don't mention angle 2 and 3 together at all, so we need to look at our picture and see, could we have gotten something from the picture? So 2 and 3 are next to each other. Those are a linear pair because they're adjacent and they're supplementary. So because it's a linear pair, that implies that they are supplementary. On this next step, so reason or step number 4, you see that the measure of angle 2 is plus the measure of angle 3 equals 180 degrees. And where did it mention angle 2 and 3 before? And that's right above it. So from this statement right here, 2 and 3 are supplementary. How can we write now that they are equal to 180 degrees? And if you think of right up here at the very top, the same thing happened before, so this is going to be the same reason. So our supplementary angles implies the sum of their two angles equals 180 degrees. On this next one, we have that angle 1 plus the angle 3 equals 180 degrees. So right here. And we don't see 1 and 3 mentioned together anywhere up above. So that means we got to look at what was given before. So they did say that 1 was equal to 2, and 2 plus 3 equals 180. And the only part that is different in step number 5 is this angle 1. So where did this angle 1 come from? And it came from way up here because they said that angle 1 was equal to angle 2. So they took this and they replaced it in place of that, and that's called our substitution property. And make sure you're writing out the whole reason, so it's a substitution property of equality. Next, we have that angle 1 and 3 are supplementary. But we have seen this before now together, 1 and 3 together, and that was a line right before it. So using just the line above it, seeing that they are equal to 180 degrees, now we can say that they are supplementary. So it's really the converse of this statement we had up above, because we're starting with the ending and then we end up with our conclusion is now what we started with. So the sum of two angles equals 180 degrees will imply that we have supplementary angles. For the very last statement, we have that angle, or line L is parallel to line M. Sorry, right there. So line L is parallel to line M. And the only reason we can say this is now if we look up at our picture. So it said we last left off with angle 1 and 3 are supplementary. So look up here, angle 1 and 3 are supplementary. And we want to know what are the names of those types of angles. Angle 1 and angle 3 are same side interior angles. And if those angles are supplementary, then that means that these two lines that are around them, so our L and M, are going to be parallel to each other. The implied statement we can write then, if you see over here on the side, if we have same side interior angles are supplementary, that implies that we have two lines that are parallel to each other. And that's our reason of why these two lines are parallel. For this very last proof, we are given two different statements. We are given that R is parallel to S, so that's my little pink lines on there. Those are the two that are parallel, and we can see that angle 5 and angle 6 are congruent to each other. That is the given. Remember, we always find that right up here in the given statement. When we look at our statement number 2, angle 4 and angle 5 are supplementary. It doesn't mention 4 and 5 up here, so let's look at our picture. So 4 and 5, if we see that our two lines are parallel to each other, and this transversal line is going through it, 4 and 5 are our same side interior angles. And we know that those type of angles need to be supplementary. So that's why this reason right here is written. So we have our two lines are parallel, so we know that the two lines are parallel to begin with, implies that we have our consecutive interior or our same side interior, remember that's the same thing, are going to be supplementary to each other. So that one was given to us. So now we have to figure out what the next statement is going to be. So remember, if we know that these two lines are supplementary, there's always something that we can write about it, because supplementary implies that those two angles will add up to be equal to 180 degrees. This means that we need to write the measure of angle 4 plus the measure of angle 5 equals 180 degrees. And our statement is already written, so the supplementary angles implies the sum of two angles will equal 180 degrees. Next, we have that 5 and 6 are equal to each other. So again, look above, see is there anything else that pairs of 5 and 6 together? And there is right here. So it takes that they are congruent to now that they are equal to each other. So how did they get it so that they are equal? Remember, it changes from congruent implies equal measures. And remember, that was the very, very first example at the top of your paper. That is a pretty common one you will be seeing in your notes and on any of the other proofs that you're going to see. For number 5, you can see that the reason is already given to you. It's the substitution property of equality. And we know we are going to have to substitute something. So look at your previous statements. We see that 4 and 5 added together gives us 180 degrees. We see that 5 is also equal to 6. So something that we could do is we could substitute this angle 6 now in place of our angle 5. And that would be our reason for substitution right here. So we're going to rewrite it. So the measure of angle 4 plus the measure of angle, and now instead of 5 we're putting 6, equals 180 degrees. And then our reason that goes with it is our substitution property. That also follows in with what step 6 is, because now in step 6 it does say that 4 and 6 are supplementary. So if you read that ahead of time, it might have led you into thinking that you need to put 4 and 6 together somehow. So that's your reason right there. And if there are two angles, 4 and 6 add up to be equal to 180 degrees, then that implies that they are supplementary. And that's exactly what we're going to write over here for our step 6. The sum of two angles is equal to 180 degrees implies that they are supplementary angles. Now, we know for step 7 for the statement is going to have to be this proof statement, so automatically carry that down. So L is parallel to line M. And the only way that that's going to happen is look at the statement right above it. 4 and 6 are supplementary. So we need to look at our picture and see where are angles 4 and 6. So angles 4 and 6 are right here. And if we want these two lines, sorry, my line's right here. If I want these two blue lines to be parallel, what do we know about 4 and 6? 4 and 6 are supplementary. And if those angles are supplementary, then we know that L has to be parallel to M. But what's the name of those angles? The name of those angles, again, is our consecutive interior angles, or they are the same side interior angles. And when we have consecutive interior angles that are supplementary, this implies that our two lines will be parallel to each other. And then that's your final reason.